Welcome to Lesson 7, example number 6, and it asks us to determine the size and length of weld required to connect it to the larger plate using E60 electrodes. It also lets us know that we have A36 steel for this plate here, this 4 by ½ inch plate, and it's also letting us know that the plate is stressed to its maximum allowable tension. All right, so when I look at this, it says, well, how much weld do we need to make sure that this plate is stressed to its max P? So first of all, we need to figure out, well, what is the max P that this plate can allow? So we go in, I'm going to go ahead and change color, go to green. I don't use green too much. But we say that, well, allowable tensile stress. So this is tension, right? So we're going to say force, axial force, or you can say force and tension. I'm used to doing force, axial force, so FA is what I usually put, equals P over A. And remember, axial is both tension or compression. I think I've mentioned that a million times, more than a few at least. Axial is tension and compression, or tension or compression. It's going straight up or down the axis of a member. All right, so there we go. So we need to figure out, well, we know the area, and we need to know what the stress is. The stress is going to be, well, the max allowable. So we know this, and we know that, and we can come up with P. So let's get A real quick. A equals 4 inch. This is of the cross section. 4 inches times 1/2 inch equals, quick math, 2 inches squared is the area. Then we look at, we want to substitute, let me change colors. We want to substitute the allowable for FA max. So small a is usually how I represent the load. So this is like actual, I guess, stress. But if you want the actual stress to be your max allowable, then you go ahead and just put that in there. So I hope that makes sense to you. If not, take a step back and just say, okay, well, if I'm putting the max allowable in for my actual, I want my actual to equal my max allowable. I think it should make sense to you. And you can go ahead and denote certain things. For instance, you could, this would, if you make your capacity, or this is your max allowable, then that will make your P is your P max as well, and you'll see that. All right, so let's go in. Now we have A, which we'll fill in, but we also need our F, capital FA, the stress of axial stress. What is your axial stress? And let me look at the tensile stress in my steel book. What's the allowable? And to tell you the truth, I just know in allowable stress design that it's 0.6 Fy, which I'm going to go ahead and write that out. But I want to know, I'm saying that FA, your axial stress, equals 0.6 Fy. And that's just from, and I know that bending is 0.66, and I know that your shear stress is 0.4 Fy. But I want to find it in the steel book so you can look it up and know where it's. And the place where I would start looking is, go see where it says spec. I would go to that, and that's the specifications. And this is really the meat and potatoes of your specifications. And if you just want to go in there and look this over, it'd probably be well worth it. The rest of actually the rest of the whole steel book is kind of just, it has a lot of tables, a lot of charts. It's a lot of good information, but the specifications are where really the meat and potatoes are. And it'll tell you certain things. So I'm going to start with specs, and I'm going to look through it, and I kind of see that it has a lot of different things. It says, it explains some loads and live loads, dead loads, and then it looks like it's got plastic design, it's got tension members, chapter D, that's what we're looking for. It's got combined stresses, it's got beams and other flexural members, plate girders, combined stresses. So that would be a good place to start. Chapter D, tension members. So let's go to Chapter D, which is 151.1, and it says allowable stresses. I'm guessing that's where we're going to find it. Does it actually say what page it's on? No, I'm just going to go to D1. Oh, there it is. Chapter D begins on 5-40, and it says tension members. All right, and that's where we're at. Okay, the first thing, D1, allowable stress. The allowable stress, FT. So let's go ahead and call it FT instead of my FA, which I also think that, I'm not going to say that. What I'm going to say, but don't hold me to this, is that compression is also the same. Compression, I believe that FA, so actually I also think FC, if it's perfect compression with no buckling or anything, I think it's 0.6 FY. But don't believe me, go look it up yourself. And that would be in the columns section. So look through there, look through the specifications, and come up with your own conclusions on that one. But once again, I'm going to do some videos about the steel manual, how it's set up, how to go through it, how to do everything. But once again, this is just to solve these problems and to give you some understanding on this. So we said we have 36 KSI steel because it's A36. A36 has a FY of 36, and I guess we haven't gone over. Most of the time you're going to see 36 KSI. I think just go ahead and assume that for your test, and I'm not going to say anything else because that just might get confusing. But there's a bunch of other different types of steels, but just remember A36. They say it's the most common, which I might have issues with nowadays. All right, I'm talking too much. Let's move on. 0.6 times 36 is 21.6. So this is our allowable stress, our allowable tensile stress is what I would call it. So this is our yield strength, our yield stress, and then our allowable. So we want to go ahead and put this up there. Let's input it into this equation. Input our knowns, and we should solve for Pmax. So we're inputting our FA, or we now said FT, our tensile stress is 21.6 KSI, which is Kips per square inch, which is what I'm assuming they worked it in. Oh, sorry, that got a little out of control. And then A, which we said was 2 inches squared. So Pmax, that's a little semicolon right there, equals 21.6 times 2, which equals, getting out of control here, 43.2. And if you look at it, that's going to be in Kips. You should just know, oh, P max, that's in Kips or pounds. We had Kips, these 2 inches, we multiply over here, and then it cancels out. All right, so that is our P max. Now we need to go in and figure out, okay, well, now that we have our P max, we need to design this weld, these two welds to stay. And I believe they're fillet welds, did it say? I'm assuming. Sure, I don't think it says exactly, but sure they're fillet welds. And once again, you have to go back to the Steel Bible, your steel book, and this time go to section J. And section J is your connections, joints, and fasteners section. And from section J, you can go, it looks like 1 page over is welds, and section J2 is welds. Number 1 is groove welds. We don't have a groove weld. Number 2 is fillet welds. There we go. And you can read through the effective area, and that's where I probably should have read through that, or maybe it pointed to it in the last video. But I would read through that definitely on 2A on page 567, assuming you have the same steel manual that I do, which I have the 9th edition. It's green. Allowable stress design. All right. And then there's also in 2B, it says limitations. You see the minimum size of the fillet weld shall be as shown in table J2.4, which is down below. And then it says the maximum size of the fillet weld. So in the next paragraph, that is permitted. I'm not going to read the whole thing. It says material, we have 1/4 inch or more. We have 1/2 inch or more, or actually have a 1/2 inch, so it's more than 1/4 inch. It says not greater than the thickness of the material minus 1/16 inch. Okay, so we have 8/16, so that'd be 7/16. Max is 7/16 inch. I hope that makes sense. Because we're doing the thickness of the material minus the 16th inch. It says unless the weld is especially designed on the drawing to be built out to obtain full throat thickness. And we don't have that circumstance, I'm assuming. So let's max out the weld. And the reason we want to max out the weld, because if you made a smaller weld, you would just have to have a longer weld. I hope that makes sense. It's going to have less strength. So the max is what we want to use, 7/16 inch. Then we go in and, so now we have for instance, I don't know if you know what I'm looking at, or what we're looking at here, but let's go back, or not go back, but draw a picture. Let's use white. And this is what we're looking at. Here's that 4/1/2 inch plate. There we go. And then there's a thicker plate underneath, which we're not going to worry about because it's huge. It's not the issue. All right, and we want to know how much fillet weld we need to put right here. So in essence, and we're doing it on the other side too, remember. Of course we can't see it because of my drawing. But we have said that this fillet is going 7/16 and 7/16. Remember, we assume that the area equals 0.707 times the length of the weld. We'll call it LW. So we said 707 times 7/16 inch. 0.707 times 7/16. Then we have to figure out, so we want to take this times the allowable, what is the allowable stress of this weld. And to figure out that, you go to page 570, and it says allowable stress on welds. We go down, we don't have a complete penetration groove weld, we don't have a partial, we have a fillet weld. So we go down, and I look at it, and I would say that it's shear on effective area. Sure, we're shearing. It's going to shear this. And then it says 0.3 times nominal tensile strength of weld metal. And then over, it says required weld strength level. Weld metal with a strength level equal to or less than match weld metal is permitted. All right, so we have a 60. So I'm assuming this is E60. So let's say it has a 60 Fy, or has a 60 strength. So we want to take 60 times, it said 0.3, and we get 18 KSI. So we take 18 KSI, so that's our allowable shear from the allowable shear stress from the weld times the area of the weld, and we get 18 times 0.309, we get 5.56 kips, and that's per inch. All right, so we say 5.56 kips per inch. We have, let's switch colors, we have 43.2, so let's go ahead and divide that out and see how many inches we need total. 43.2, I'm gonna write it up here. Kips divided by 5.56 kips per inch, and we're going to get inches. 5.56, 7.77 inches. So what I would do is round up to 8. Know we have two sides, so we can get 4 on this side, 4 on that side. So your answer is 4 inches. 4 inches, 4 inches. I'll see you in the next video.